This tutorial shows you how to convert from a PHYML file to a FASTA file and vice versa. It also shows you how to convert a FASTA file to a NEXUS file. These conversions are often necessary when working with population genetic data. This tutorial assumes you are using Ubuntu Linux version 20.04 as your operating system. If you do not have Linux, you can emulate it on your Windows or Mac computer for free. See the show notes for details. In fact, I am emulating Linux right now on my Mac computer using VirtualBox. I have a VirtualBox virtual machine pre-configured with the software I will show you today, as well as other population genetics and ecological niche modeling software. See the show notes below for step-by-step instructions to download and hook up this virtual machine within your Windows or Mac computer. This tutorial assumes you have RStudio installed on your machine, which also requires R to be installed. This tutorial also requires that you have Mesquite installed. Or you can skip this whole tutorial if you want by just downloading the VirtualBox virtual machine I have created that is already pre-configured, and you can run Linux in virtualization on that virtual machine using the pre-configured software. Let's get going. The first step is to open up a web browser. If you have one pinned to your favorites, you can open it from here, or you can come down here, click this button for the search, and search for one of your web browsers. Visit my website, joshbanta.com. Click on Tutorials. Find where it says How to Convert Between a PHYLIP and FASTA file, and click on Files Needed for Tutorial. Wait for the entire page to load, and then select the Download button and select Direct Download. When the download is complete, you can close your web browser. Open up File Explorer, which you may have pinned to your favorites like me, or you can search for in the Applications. I'm sorry, I was showing you this one. I should have been showing you Files. Go to your Downloads folder. Double-click the file we just downloaded, phyfast.zip. This pulls open a program called Archive Manager, which looks inside of the compressed folder archive. Next, come back to your File Explorer. Let's put this folder on our desktop. Drag the folder phyfast from the Archive Manager program onto your desktop of your File Explorer. You have now extracted the files from the archive, and you can close the Archive Manager. Next, we will open up RStudio, which you may have pinned as your favorite or which you can search for from your applications. This is a teachable moment. I had an R script open in RStudio that I have since deleted. When I opened up RStudio, it's still looking for that R script, but it can't find it. It asks me, do you want to close this file now? I'm going to click yes. But if you weren't sure, you could click no, and you could save this R script and then close it. Next, we're going to open up the R script that we're going to use to convert from a PHYML file to a FASTA file. Go to File, Open File, go to your desktop, open up the phyfast folder, and select phy2fas and then push open. The first thing we have to do is set our working directory. This tells RStudio where to find the files that we're converting. Session, set working directory, choose directory. Navigate to your desktop. Select the PHYFAS folder. We want to select the entire folder. Do not double click. Select this entire folder with a single click and then press open. We have now set the working directory. Next, we need to install the package called ape. Highlight install.packages, etc., on line 5, but do not highlight the hash symbol. Then press run. The console window down here shows us what R is doing when we execute commands from the script. That process took about 2 minutes. Next, we need to call the library that we installed. So we highlight line 7 and press run. A note about line 5, where we installed the package ape. You only need to do that once. For the rest of the time that you ever use RStudio on this computer, you never have to run line 5 again. But every time you open up RStudio, you will need to call the library. You will need to run line 7. Let's take a quick look back at our files that we downloaded. There's a file here called sampledata.phy. This is our sequence data in PHYLIP format. If you double click on it, you can see that there is DNA nucleotide sequence data here. D1, D2, D24, etc. are the individuals. This command here takes that PHYLIP file and reads it into R. So highlight line 11 and press run. Next, we need to save that data in the FASTA format. We do that by highlighting line 13 and pressing run. An important note. This tutorial uses sample data, which is data that I provided to show you how to do this, and I named the sample data sampledata.phy. If you're doing this for your own project with your own data, you're going to need to change this piece of code here from sampledata.phy to the name of whatever your actual data is called, whatever the name of your file is actually called. You have the option too of changing the name of the FASTA file that is produced if you would like to. Let's go have a look. So if we go back to our desktop and we go back into PHYFAS, there is the FASTA file that was created from the PHYLIP file. And we can see now that the data is now presented in the FASTA format. But what if you wanted to go the other way around? What if you wanted to convert from FASTA to PHYLIP? Well, let's close the script that we have open, and we'll open up a new script. File, open file. This time, we'll select the script fas2phy and press open. Even though the working directory is now set properly, let's reset the working directory just to be safe. Session, set working directory, choose directory. Go to your desktop, click only once on the PHYFAS folder, and select open. Now we can be certain that we're in the proper working directory. This command on line 5 we do not need to run. we never need to run it again. But this command on line 7 we do need to run. Actually, we didn't need to run it because we've kept R open this whole time, but just to be safe, it's always a good practice to run line 7 here again and call that ape library every time you want to run one of these file conversions. Now let's look at line 11. Here, we're taking a FASTA file and we're reading it into R. Last time, we took a PHYLIP file and read it into R. This time, we're reading in the sample data that I provide to you called sampledata.fas. Let's have a look at it in File Explorer. So if I double click on it, we can see that we're starting out with a file in FASTA format. So we'll highlight line 11, and I emphasize again that with your actual data, you will need to change the name of this file here to match the name of your actual FASTA file that you're working with for your real project. For doing this tutorial, you keep this the same because you're just using my tutorial data. But for your actual research, you'll want to change this file to match the name of your actual FASTA file. Highlight line 11 and press Run. Next, we need to actually make the PHYLIP file from that FASTA file that we read into R. Highlight line 13 and press Run. If you like, you can change the name of the output file. Just make sure to keep the PHYLIP file extension. All right, let's see if it worked. We'll open up File Explorer. We'll go back to the PHYFAS folder. And the file we're looking for is output.phy, output.phy. And we can see that it took our PHYLIP file and it converted our FASTA file and it converted it to a PHYLIP file. Finally, I will show you how to take a FASTA file and convert it to a NEXUS file. But what if you have a PHYLIP file and you want to convert to a NEXUS file? What I would recommend you do is first convert that PHYLIP file to a FASTA file using the methods I have shown you how to this point. Then you could take that FASTA file and convert it to a NEXUS file. If you're already starting out with a FASTA file, you can just start here and take that FASTA file and convert it to a NEXUS file. For this, we're going to close out of RStudio because we'll be using a different program. So I hit the close button over here and it asks me if I want to save the image. It's asking me if I want to save the output from the console. I don't, so click Don't Save. Now, if you had made changes, I should show you here. Let me pull this open again. If you had made changes, for instance, changing the name of the file in here, you would need to save it. You would need to do File, Save As, and save the script. Otherwise, you would lose the changes that you made here. But as long as you didn't change anything up in here in your script, when you exit out of RStudio, you don't need to save anything, even if it asks you. But if you did change something in that script, for instance, the name of the file to match your file, you're going to want to go up and hit File, Save As, and save the script. But let's get back to talking about converting a FASTA file to a NEXUS file. For that, we're going to open up File Explorer. And we're going to navigate to the folder where you keep Mesquite. If you're using My Virtual Machine, click on the Home directory and scroll up. Double-click on Bin, and then click on Mesquite folder. Now, open up a terminal window. If you don't have terminal pinned to your favorites, you can always find terminal by searching down here. Type in CD and then space. Now, capitals versus not capitals matters very much. So if you see lowercase on my screen, you should be using lowercase on your screen. If you're seeing uppercase on my screen, you should be using uppercase on your screen. So type CD space. Then we're going to get the path to where we keep Mesquite. So you're going to take this folder drag it up into terminal. So now we have cd space the path to the Mesquite folder. Press enter. Now you need to type exactly what I type. Java, all lowercase, -jar. There's no space after the dash and the jar. Space, capital M, the rest lowercase, mesquite.jar, lowercase. But note the capital M in Mesquite. Press enter. Now we will load in our FASTA file. Go to File, Open File, go to your desktop, click on PHYFAS, click on sampledata.fas, and click Open. The file that we have is a FASTA file of DNA. So highlight that and click OK. It will automatically save a NEXUS file. So let's clean up the name of the NEXUS file that will be created. Go ahead and delete .fas. Let's save our NEXUS file as sampledata.nex. But now this is important. We don't want to save our file sampledata.nex within the Mesquite folder, which is where it's going to be saved now. We want to save this file back in our folder with all the rest of our genetics data. So be careful after you've changed the name of the file. Don't just hit enter or hit save. After you've changed the name of the file, come back to your desktop and click on PHYFAS. Double click on PHYFAS. Now sampledata.nex will be saved in our PHYFAS folder along with everything else so that we will be more easily able to locate it. Click Save. The reason that Mesquite went ahead and made this NEXUS file without even asking us if we wanted a NEXUS file is because the Mesquite population genetics software works natively with NEXUS file format. So if you give Mesquite a file that's in a different format, Mesquite will automatically convert the file into the NEXUS format so that it can work with it in the format that it's designed to work for. But the side effect for us is that it automatically generates a NEXUS file for us that we can then use in other software that also requires NEXUS files. So we now have the file in NEXUS format, which I will show you. Click File, quit Mesquite, exit out of Terminal, go back to your desktop, click on PHYFAS, and there's sampledata.nex. Let's double click on it. And this is what the genetic data looks like in NEXUS format. So we have successfully performed the conversion to NEXUS format as well.